Here we are, and we are going through a paper. How fun is this? So here we have the 2024 paper 4-1, okay? Physics, of course. Cambridge IGCSE physics, and we are trying to see how we can do this one. Let's enjoy. So I'm going to say, Team Clarify. Time to go through the series, and we're going to do it as fast as we can, enjoying, making ourselves as good as we can, preparing ourselves for the exam, doing everything right. Are you ready? Let's get to work. So we're going to go through it. So what I want us to do is just take note of this, that the weight is 9.8. We're going to be using we can just say G, the gravitational field strength or acceleration due to gravity. So when we're using it as field strength, it's going to be 9.8 newtons per kg. That is when we are doing calculations around things like power, energy, work, whatever, and we need gravity, we're going to be using newtons per kg as long as we have a force. Then for motion, we're going to use G as an acceleration due to gravity, and it's going to be 9.8 meters per second squared. Are we together? 9.8. All right, so it's not 10, it's 9.8. Now let's get to work. What I want us to do first is the calculation questions first. We want to quickly go through calculation questions, and when we're done with those, we are going to now do theoretical ones. I want us to do the questions that say calculate or determine, and we want to do them together with an incredible amount of energy. So let's just say, let's put some things that we are going to need, okay? I looked for some free space on your paper, and I'm going to write this, and this is probably you with a pencil, and I know I'm going to say, okay, in general physics. What do I have? General physics is like unit 1, okay? They've renamed it since the 2023 to 2025 syllabus calls it motion, forces, and energy, okay? So we can call it motion, forces, and energy. So we are talking about here, I'll be dealing with things. First of all, I'm going to be teaching you to do the calculation questions. Calculate. Then we're going to do questions that involve diagrams, ray diagrams, graphs, drawing the graphs and whatever. Then after that, we'll talk about some theoretical questions. We'll see how it goes. It's going to be fun. So we're starting with the questions that say calculate or determine. So from unit 1, we have 6 units in physics, and here's unit 1, which is motion, forces, and energy, okay? And I'm going to skip the stuff for motion, okay? I'm going to skip that, and I'm going to start from forces, okay? Now, when you talk about forces, first you have to know the types of forces, whatever. Then when you start to do calculations, you're going to do calculations that involve motion where there are forces involved, and forces bring acceleration, right? So we're going to be dealing with motion where there is an acceleration, and when there is an acceleration, maybe it's something falling in air and stuff like that, we have a force, so it causes an acceleration, and for that we're going to be using what we call Shewhart equations for motion, okay? Which is 2 for V, 2 for S. So V will be equal to U plus AT. Then we have another one which is V squared is equal to U squared plus 2AS. Then we have another one which says S is UT plus half AT squared. Then we have another one, say S is V plus U over 2 times time. All right, no problem. We'll just have them, okay? Right, this is for Shewhart equations, motion involving forces, and there's the other one which we're going to use a lot, which says the resultant force is equal to mass times acceleration. This is Newton's second law. All right, this is Newton's second law. We're going to use it. If we can get the resultant force, we're going to use the idea to say resultant force is equal to mass times acceleration. Now, what is the other thing that we should know? You should know the idea. We'll be moving. It's still the same unit 1. We're going to have again under unit 1, we're going to have moments, okay, which will be the turning effect of a force. We want to find how much if a force will cause something to turn. So you're going to say force times the distance from the pivot, okay? And you're going to get the moment. You understand? This is going to give us the moment. Then we're going to have again momentum. Okay, and momentum is just going to be this standard P. It is going to be mass times velocity. Now, in momentum, there's a law you must know, which is going to be the law of the conservation of momentum. First, let's talk about this thing called impulse, okay? There's going to be this thing called impulse, which is going to be a change in momentum. And for change in momentum, it will be mass times change in velocity. Because we can't say it is change in mv, because the mass can't change. Okay, we know momentum is mv, so delta p should have been delta mv, but mass can't change, so bring it out. So it is mass times change in velocity. And change in velocity, we know is just final minus initial. So we're going to work on that. This is going to be the impulse, and it is also okay? So it'll be like mass times change in velocity, which is mass times the final minus initial, okay? Velocity, okay? And it is also force times time. These all give impulse. These all give what? Impulse. So here we can find impulse. It is what causes a change in momentum. In moments, there's something which you must know, which you're going to know a lot, is that when objects are in equilibrium, we say that the sum of anti-clockwise moments is going to be equal to the sum of clockwise moments. This is, we call it the principle of moments. There is a principle which we use. So first you should know the formula of moments, then you must know this, which we call the principle of moments. If you add all the moments that cause something to turn clockwise, they should be equal to something, to all the moments that cause it to turn anti-clockwise. And we call this the principle of moments. Okay, we call this the principle of moments. Are we together? And then we've seen momentum, and we have the law of conservation of momentum. We also should know that one, okay? The law of conservation of momentum. It says that if you have a closed collision means you have two things colliding, you have two things coming together, and there are no external forces acting, then you must know that the sum of the momentum before collision, we say the initial momentum, is equal to the sum of the final momentum, which is the momentum after collision. Do not forget this, come on. This is all coming under momentum, okay? On moments, you should know moments and the principle of moments. On momentum, you should know momentum and the law of conservation of momentum. Are we together? Okay, so there's going to be the conservation of momentum. Then we're going to have again energy, okay? Right? And for energy, the energies that we calculate are kinetic energy, which is equal to half mv squared. Then we're going to have gravitational potential energy, and we say that the change in gravitational potential energy is going to be mg delta h. You understand? And these are the two energies that we calculate. So these are the only two energies that you calculate directly. Now when you have it, you are going to use the law of conservation of energy. Sometimes to work with this system that we have, it says that energy is never lost or created, but it's just converted from one form to another. Now what I want you to know is that we can have the kinetic energy changing to potential energy, and then we can have the potential energy, the GPE, changing to kinetic energy. They can interchange, okay? But sometimes you may have some wastages. So you'll be now saying, okay, total energy will be equal to, total energy is equal to the total energy in, let's say the total energy into something will be equal to what? The total energy that was in something is equal to the total energy that is brought out by that machine plus the wasted energy. This is an important thing to remember. Okay, you should remember this on the law of conservation of energy. Sometimes it's waste. All right, sometimes there is waste, and we're just going to have that. Now, as long as we're still on energy, let's talk about work, because work and energy are directly related, okay? So we should know that work is equal to force times distance, okay? Similar to the formula for momentum. For moments. But what you must know is that the work will be the change in energy, so it will end up be work. Okay, work is going to be change in energy, so if you can find it work, then you're going to find it. Okay, delta E. Are we together? Which is the change in energy. Energy transferred. It's just the energy transferred into or out of something. Now let's talk, we're not yet done. Let's talk about power, okay? Power will be equal to the rate of doing work, or it is also the rate of converting energy from one form to another. This gives you the power, okay? This gives you mechanical power. Work done over time taken, or energy over time taken. Okay, are we together? Then finally, we'll be having one more thing which I want to talk about. Is going to be called efficiency. Okay? Right, there we have it. In efficiency, it is going to be what? What is the efficiency equal to? We say that efficiency is going to be equal to useful power over, okay, it could be power or energy. Useful power over the total power input. Okay, that's what happens. This gives us efficiency. So we'll be saying the useful energy output divided by the total power input, or the useful power output divided by the total power input. But we like to present as a percentage. So you say times 100%. Don't forget, you're going to say times 100%. okay, times 100%. When we are using energy, it's the useful energy output divided by the total energy input times 100%. And this is going to be the formulas we're going to use in Unit 1. Have you seen them? Now, we should never meet a Unit 1 question and not be able to do it. Oh, yes, there's one more thing I need to put, which is Hooke's law. And Hooke's law says the force is equal to... Here, Hooke's law, it says that the force is equal to the Hooke's constant times the stretch, okay, times x, which is, yes, your x is going to just be, so it will be our extension, the x, right? X will be our extension, and then k is the Hooke's constant. Then we can find the force. We want to see how much a force will stretch something, so these are just effects of a force, okay? And this is what you should know. I don't want you to forget anything on this list, and we're going to be able to find whatever we need. Oh, okay, one more thing is the pressure at the end. You should know that pressure is force over area. This gives us pressure. And then when we're looking for pressure in liquids, we say that the pressure is going to be equal to rho GH, okay? This gives us the pressure in fluids, okay? And this is going to be it. That's it. And now let's start and let's see if we can do. We want to do calculation questions from week 1, from lecture 1. If there's anything to do, then we'll see. Now let's get to work in the next video. Goodbye for now.